Thank you, everyone, for joining this NetApp IT's use of Trident for DevOps automation. Today, we have David Fox, who is the NetApp Platform Engineering Team Lead. Dave serves as the Platform Engineering Team Lead at NetApp, where he specializes in designing and deploying services on Kubernetes. His role involves leading a dynamic team to implement innovative solutions that enhance containerization and automation within the company. So without further ado, David, take it away.
Good deal, Chris. Thanks for the introduction. Again, my name is David Fox, Platform Engineering Team Lead within NetApp IT. And today we're going to talk about DevOps automation with Trident. So on the agenda, first we're going to talk about what our cloud journey looks like. We've been on this journey for quite a while. We're going to talk a little bit about what that journey has looked like. Secondly, we're going to talk about Kubernetes and talk a little bit about how that fits into the journey. Additionally, we'll be discussing how Kubernetes actually helps us from an application developer perspective. And then lastly, we'll discuss how does Trident really fit into the picture and how does that actually facilitate the application delivery process. So brief history of our journey. I've started at NetApp in 2014. And at the time when I started, the way that we delivered applications is, so if you've been in the industry long enough, you'll remember this. Sort of kind of like a manual deployment. You gather like the domain architect together with like storage engineering, compute engineering, network engineering, and you'd have a meeting or a set of meetings, and everybody would write down their to-dos and then go their various ways, right? And maybe compute takes 3 days to get back with compute. Network takes a week, and storage takes like a day or two, right? And then we, come back together and sort of kind of put together the pieces manually. Cross fingers, hope it all works. And, that was really how we delivered applications. And, the result was it was taking weeks, if not months, to deliver even relatively simple applications because, we had to manually interface with all these teams that then had to manually do the work, right? Obviously, there was room for improvement there. So what we started to do from that point is what I'd call automation in silos, right? So, the storage team would have WFA to automate storage, and then the network team and the compute team might use HPO or Ansible to automate the computer network, right? And then storage might have scripts to automate storage building, right? But we were still in that almost manual model, right, where we'd all come together, we'd all sit down and discuss what we need. But we had some automation in silos, which ultimately helped us deliver things a little bit faster. But it was still taking days or weeks to deliver the full product because we weren't approaching the problem in a cohesive way. Around that time, we noticed that a lot of app teams were going to public cloud, right? And they were doing it for several reasons, right? One, it was easy, and two, it was relatively cheap, right? So they didn't have to, get everybody in a room together just to get compute, network, and storage. They could just go swipe the credit card and Amazon and get what they need. But this presents problems from a business perspective, right? Because now we have what's called shadow IT. There are people that might be operating applications, without governance, without security guide boundaries set up, that kind of thing, right? And so, noticing that people wanted an easier way to deliver applications, but also noticing that the business needs sort of kind of guardrails and governance around that process, we started with what's called NetApp in cloud, right? And this was sort of kind of IaaS focused. Again, if you think about Amazon, you get the, your dashboard, you can deploy EC2 instances like really easy, and then set up load balancers really easy and all that stuff. And so what we wanted to do is still, be focused on IaaS, right? But bring some of that automation that we already had in silos, right? And make a more cohesive picture out of it. This is still very much IaaS focused, right? So it's like, here's your compute, here's your network. It's up to you to deploy the application, right? So that was still very much manual. But at least we were able to deliver the IaaS quicker, right? But, obviously, the infrastructure is not just for the sake of infrastructure, right? We want to deploy applications on top of it. And so with that realization, we started to bring together even more of the picture, and that led to what we call NGDC, right? And that was more of a cohesive, holistic approach to not only infrastructure delivery, but overall application delivery. And then that morphed into what we have now, which is our NetApp hybrid cloud, right? So, again, everything's self-service. We offer infrastructure as a service as we always have, but now we've got more focused on DevOps as a service, right? And we'll talk a little bit about DevOps as a service and what that means later. But the goal here is to really bring together infrastructure, applications, security, into a single self-service portal that allows application developers to get precisely what they need quickly, right? So, why are we doing on this, right? This is going on a decade journey, right? And the answer is actually pretty simple, right? The expectations of the application developers have changed over time, right? Long gone are the days of, like 2014, where I was talking about, we all get in a room and discuss it and everybody goes their separate ways and, comes back with their piece part, individually. And, eventually you get your application environment. No, things need to be more cohesive. They need to be self-service, but at the same time, it needs to be more than just infrastructure, right? We realize that, infrastructure is only half the battle, right? We need to enable application automation, automated application deployment, as well as infrastructure deployment, right? We need to give people simple choices, right? So, we've got a service catalog. Pick X for your app stack, right? Sort of kind of size your app stack. Is it a large application? Is it a small application? Simplify those choices, and then have some ready to use boilerplates that go along with that, right? So, making sure that people have not only, all the infrastructure and whatnot that they need, but they've got some sample like hello world code, right? That comes with whatever application that's in our application portfolio that they could choose from our self-service portal. We wanted to, simplify the developer experience also by, taking their hands off the infrastructure. That way they don't have to worry about it. We'll automate that for them. And then that way they can focus on the application. And what this ultimately ends up in is a paradigm where application developers can increase their velocity and ultimately reliability, because they're not having to worry about bringing all the parts together. We're doing it for them. We're doing it in an automated fashion, right? And all this is self-service through a service portal. So, what this portal looks like, what it actually brings to the table, is really a one-stop shop, right? Where application developers can go to a self-service portal. They can order IaaS if they want to, or if they've got their own containers and they just want to deploy, some container that they've built on the side, but still leverage our CD process, right? There's container as a service. But if you want sort of kind of like the full-blown service, right, where we're offering you everything, we've got the DevOps offering, and we're going to talk about that today, right? Also, we enabled application developers to order these resources wherever they want to, right? It could be, a cloud provider, it could be on-prem, it really doesn't matter. All this is exposed to them as an option in the self-service portal, and we've got all the guardrails in place from a governance perspective to make sure that, while they're getting things quickly, we're still meeting, compliance and governance specifications. So again, today we're going to talk about DevOps and DevOps as a service, right? And so let's talk a little bit about what that means, because I've already mentioned it once, right? DevOps as a service is an end-to-end offering where we're not only offering a platform where app developers can host their code, we're also giving them a cloud agnostic way of deploying their applications through a CI/CD pipeline. So we create the pipeline for them. We create all the Artifactory repositories for them for their Docker images, right? We're giving them a Git repo, and we're giving them the security tooling, all the logging and the metrics, So, we've bundled all this for them so that, as if, you know, they don't really have to think about it, right? So if you think about IaaS, right, you just get some compute, and then you've got to go figure all that other stuff out yourself. We wanted to take that away from the developer so that they don't have to worry about it and they can focus on code and ultimately delivering that app that brings value to the business and ultimately the customer more quickly. So our self-service portal is ServiceNow. And in ServiceNow, if you choose DevOps, you've got sort of like a service catalog where you can choose different pieces, parts in terms of app stack that we've curated. We have what we call boilerplates for that you can choose from. So like if you've got an application that requires Spring Boot and MongoDB or Nginx and MariaDB or whatever that combination is, right? We give that option to you in the self-service portal. Additionally, we combine that with, some, infrastructure and artifact primitives such as, the automated building of Docker images, the automatic creation of Helm charts, the automatic deployment to Kubernetes, the automatic day one of even onboarding, right? Setting up, your namespaces and whatnot that you're ultimately going to deploy to. And then we're also giving you the choice. Do you want to deploy to private cloud or do you want to deploy to public cloud, right? So all that is self-service. The developers get to choose. And then ultimately what happens is they get the ready to go code within 30 minutes or less. So this is all like an automated onboarding process. So again, we're starting with our ServiceNow portal with the self-service catalog. You get to choose what you want out of that catalog, as I was just mentioning. Choose your application components, size your project. Is this, a large project? Is this a small project? Whatever the case may be. And once you go through those steps and choose what you want out of the service catalog, this is the app I want. This is the cloud I want it to live in. Few things happen. First, we update CMDB to, sort of kind of record, hey, we've got this application that's onboarding, and here's some of the, properties of that application, like what tier it is, et cetera, right? But simultaneously, we also kick off our day one automation on Red Hat Automation, Ansible Automation platform. And on this, we have Ansible playbooks that will go out and do several things, right? So first of all, it gives application owners a Docker registry. It sets up LDAP groups through a tool we call Neat, right? We then use these LDAP groups to set up a role-based access control in our Kubernetes environment. And then the day one automation also puts guardrails in place. So we put a quota in place, limit ranges in place, of course, the RBAC, like I just talked about, and all that stuff. And then finally, this day one automation delivers everything in Azure DevOps that they need to really get going with Hello World code, very quickly. So that includes a Git repo with the Hello World code, the RBAC to say, who gets access to the code and at what level, who can commit, who's read-only, et cetera, et cetera. We set up the CI/CD pipeline, which includes all the security scanning and whatnot, right? So we're giving them this end-to-end experience, which ultimately culminates into what we call a DevOps workspace, right? So once you get all of the primitives in the middle, you can then deploy to the workspace. And essentially what a workspace is a development space, right? So now that you've got your Hello World code, you're ready to get going, you can make whatever changes to that Hello World code and deliver to your workspace and instantly see results, right? This whole process for day one automation takes 20 to 30 minutes. So that's a lot better than what we were looking at back in 2014, where we're talking, days, weeks, maybe even months, right? And that there's obvious benefit to that in terms of enabling application developers to quickly deliver value to the business and ultimately the customer. Once you, are happy with code in your development space, you can deploy to host spaces, which you can have staging host spaces or production host spaces, right? And all this is stepped through in the CI/CD pipeline, as we'll see in a little bit. Well, that sort of kind of begs the question, where does Trident come in, right? What does Trident do? Well, if you think about what Kubernetes does, right? Kubernetes is a way of defining what your application looks like, not only in terms of, hey, my application is this Docker image in this repository, right, that we've set up for them through our day one automation, right? But it also contains things like this is the compute I need. So I need to, I'm requesting 4 CPUs and 8 gigs of RAM or whatever it may be, right? So you're declaring what you need from an application perspective in terms of like network, right? So I want to expose my API, via the host name api.mycompany.com, right? So you declare your network needs, you declare your compute needs, right? But your application also needs storage. And so what Trident does is it allows people to declare their storage requirements in Kubernetes, and then Trident goes out and fulfills that, right? And so all this happens automatically. There's no need for manual intervention. The application developer simply declares what they need in their Kubernetes manifest, and then Kubernetes and Trident take care of it automatically, no manual intervention required. So let's talk about day two, right? So we've talked about day one, applications onboarded. They've got their hello world code. They've got their Docker repository, and some, Helm or Helm charts that declare all the compute and network and storage needs, right? So they start off with that hello world code and they say, hey, I want to make a change. I want to make this a real API, right? So they make changes to their Git repo and they push that change to the Git repo. And what that does is it starts the CI/CD process. The first stop is building the image. Now that you've checked in code to your Azure DevOps Git repo, the image build kicks off. Once the image build is done, that image is pushed to Artifactory, which is our Docker repository, is where all of our container images live within IT. At that point, we go through several security scans, not only in the pipeline, but also continual security scans with various tools to make sure there are no outstanding CVEs or whatnot. Once the security scans complete and pass, we then combine our image with those Kubernetes manifests that define what our network needs are, what our compute needs are, and what our storage needs are, right? Kubernetes and Trident then deliver upon those needs, right, in the development workspace. So you get your storage, you get your compute, you get your network, right? And it's all to the developer specification. So once they are happy with things in development, hey, this looks good, let's promote it. Let's go into a staging environment. This is a staging host base. Again, we're going to combine that Docker image with our Kubernetes manifests that define what our compute, storage, and network needs are. And then, a QA team or whoever is going to examine the final output in staging. And eventually they're going to say, hey, this looks good, right? That goes on to quality checks, right? So if you've got like a QA team, LMP team that needs to run a performance benchmark on the application, they get to sort of kind of do this at that step, right? Looking at a staging host base. And then once they're happy, we once again, combine all of our artifacts from our Docker repo with our Kubernetes manifest defining what storage, compute, and network needs are. And then we've deployed to prod. If going back to this slide, if you were to just, just check all along the line, going from development to production could take as little as 20 minutes, right? So again, big change from the old days where it would take, days, weeks, or months, right? So we've shrunk that down to literally minutes. From an application perspective, when they request storage in particular, right, we've abstracted the various storage backends from them. Again, in Kubernetes, you define what your needs are, and in this case, Trident delivers on those needs, right? So if you need a 50 gig volume that's read write once, where only one pod can, talk to it, Trident's going to go provision that, and if it's on-prem, it's going to provision it, in our case, on all flash fast, right? if that same request comes through and it's in the cloud, it comes from FSXN, right? The application developer doesn't know where it's coming from and doesn't really care. All they know is they have a certain need. They've quantified their need, defined that need in a manifest, and have applied it to Kubernetes. And between Kubernetes and Trident, that need is automatically met. No manual intervention required. And so, with all that said, we've done a lot of work. It's been like, a decade-long journey to get from where we were to where we are. What's the real return on investment here? Well, if we look at our current production environment, right? As of the time I put together this slide, we had a total of 532 volumes and 98 terabytes served, right? If we just take the amount of average time that a storage admin, if they were dedicated to the task, right? So no other work on the plate, whatever, right? And they had to manually do this. If we assume 15 minutes to create the volume, set up the export policy, we've saved 5.5 days. That's assuming they didn't do anything incorrectly, right? Because, humans make errors. That's why we automate. But we've saved 5.5 days, which doesn't seem like a terrible amount of time saved, right, for such a long journey. But let's be realistic. That's not the application developer perspective, right? Typically in, the old way of doing things, you would submit a request through whatever ticketing system, BMC Remedy or, ServiceNow or, whatever you use, right? And that storage engineer is going to get the request. Maybe they got some other things on their plate. They're doing data protection work or, auditing work or working on somebody else's request. And so realistically, and this is based on like several past lives of experience, you're talking, about a day to get what you've requested, right? Some organizations are better, some are worse, but I figured about a day just based on my personal experience. And so from a developer perspective, the time saved is actually 532 days if we assume it's like 1 day turnaround time between when you request what you want and you get what you want, right? And that's a massive savings, right? That's like a year and a half. And so that's a big return on investment. So if we take all this, what we talked about, here are the key takeaways, right? Number one, you've got to automate and you've got to make it self-service. Long gone are the days of, pulling together a domain architect and a big team and, everybody doing everything manually and coming together at, after weeks or months and hoping that it works, right? App developers need stuff now, right? And so automation and self-service are key to delivering on that so that they can deliver value to the business and ultimately to the customers quickly, right? Takeaway number two, Trident allows us to self-provision storage in a Kubernetes environment. So again, leaning on point number one, we want to make that storage provisioning really easy for end users, so that number three, when we combine it with Kubernetes, Trident and Kubernetes come together in a way that allow the end users to self-service themselves so that they get network, storage, and compute quickly and in a self-service fashion. This increases overall developer velocity and ultimately reliability because now that you can ship code and updates quickly, you can make your application more reliable over shorter amounts of time. So that's my presentation on how we're using Kubernetes and Trident together. So if anybody has any questions, feel free to ask.
David, there are a couple questions here. First, I'd like to say there are 3 short questions and polls that we'd love your feedback on. But as far as the questions go, the first one, before Trident, how did you deliver storage to containerized workloads?
Yeah, that was a really interesting time before Kubernetes 1.4. So, we've been using Kubernetes in production since 1.3, before the concept of a dynamic volume provisioner like Trident existed. And what we would do is we would essentially pre-seed the cluster with various types of storage, right? So we'd have a bunch of 10 gig volumes, a bunch of 100 gig volumes, a bunch of, 1 terabyte volumes, right? And then, hope that people use it in the way that we intend them to use it, right? There were a couple of problems with that approach. One, you were already over provisioning storage, right? Hoping that people would use it. And so, if somebody came along with like a request for a 50 gig volume, and all you have is 10 gig, 100 gig, and 1 terabyte volumes, well, they're going to get the 100 gigabyte volume, right? So they're already getting more than what they need. So you've really over provisioned in two ways. And then the second problem is that you always seem to run out of a certain type of storage before others. And so now they've got a persistent volume claim out there where it's not bound because they can't find anything that's appropriate, right? And so we would constantly have to be checking on that and making sure that we were preceded with the the right flavors of volumes that people might need. So it was better than what we were doing, but still not ideal because people weren't necessarily getting exactly what they need in precisely the time they asked for it.
All right. So second question we have is approximately how many applications are you running in the production environment?
So right now, we're running approximately 60 applications across 6 different Kubernetes environments. And then, of course, we have our development Kubernetes environment, going back to the workspaces I was talking about earlier. So it's a total of 7 clusters, right? That's a combination, in our case, of applications in Kubernetes clusters out in US East 1, US West 2, and then we have our on-prem data center in Hillsboro. And so they get to choose where they run or whatever. But the total as of the last time I looked was approximately 60. And those range from like big applications like our support site to smaller applications like our employee lookup directory, right? So it's like a hodgepodge of a bunch of stuff.
And then another question, what storage protocols are you using to deliver storage to Kubernetes?
Okay, yeah, great question. Today, we're using strictly NFS, right? But Trident doesn't restrict you from using only NFS. If you wanted to use block storage, Trident will deliver iSCSI. And I think Trident will even deliver Fiber Channel if you had that in your environment. But don't quote me on that. It's been a long time since I've looked at that documentation. But for our use case, we found that NFS is really sort of kind of the protocol of choice. And that's where we use everywhere, public cloud and on-prem.
And actually, we have a question in the chat. Is Trident open source?
Yes, there is a GitHub repo for Trident, and so I believe it's open source. Open source means different things to different people. I don't know what the license is, so I'm pretty sure it's not like AGPL v3, but the code is available on the GitHub. The last I looked.
NetApp Trident is licensed under the Apache license 2.0.
Okay, great. Yeah, so that would be like an open source license.
All right, well, that is all the questions that we have. I appreciate everyone for joining. And again, if you could take the time to fill out those 3 poll questions, that would be very helpful in making sure these webinars are beneficial. David, thank you very much for your time and your expertise. And thank everyone for joining.